Hey guys, so today we are just going to focus on taking notes on solving multi-step equations. That way we become more familiar with the terms, more familiar with the solutions that we need to be looking for, and how to feel comfortable enough to decide that we are done solving the problem. So we're just going to take one page of notes today. Feel free to abbreviate anything, write it in a way that's easiest for you to understand. It doesn't have to look exactly like what I have on my paper. So we're going to get started. We are solving multi-step equations. With this, you need to understand what the word multi-step means. So we have solved one-step equations and two-step equations. Now we're on to multi-step equations. So what this means is it's more than two steps. So if you know that you're given an assignment over solving multi-step equations and you only did two steps to get your answer, odds are something might be incorrect and you should double check. It should take you more than two steps in order to get an answer. The next thing that I want to talk about are the different types of solutions to the problem that you could get. So I'm going to call this our finish line, is how you know when you're done solving. Like, what do you look for? How do you know when you're done solving the problem? I've seen lots of papers where students thought they were done, but they weren't, and they still had a couple steps to go. With multi-steps, you don't know how many steps it's going to take. Each problem is different. So here is what you need to know. You are going to end up with a value equal to another value. This could be a variable value, it could be a number value, but it's going to be by itself. I'm not going to have x plus 5 is equal to 2x plus 9. No, it's got to be just one value equal to one value. Here are some examples to make that more clear. The first example is x equals 5. I have the value x equal to the value 5. This is a one solution problem. I have a variable equal to a number. There is one solution for this equation, and that solution is 5. So in this case, you would just say x equals 5. That's my one solution. The second example that I want to show you is when you get something that looks like this. You have a variable equal to a variable, or a number equal to a number. So basically you have the same value on both sides of the equal sign. The left side looks just like the right side. They have to look exactly alike. They've got to be identical twins. This is a true statement. Y does equal Y. 18 equals 18. Those are true statements. So what that means is all real solutions is your answer. You don't have that definite one answer like you did in number 1 and can tell me what it is, but instead, all real solutions is your answer, and this is what you would write for your answer after you're done solving the problem and proving that it is all real solutions. The third type that I want to talk about is when you have a false statement. So in this case, 32 does not equal 12. X does not equal Y. Anytime the statement is not true at the very end, you're going to put no solution because it's not true. Okay, so those are the three different types of solutions that you can have. Those are the three things that you can be looking for when you think that you're done solving the problem. You should end up with a value equal to a value, and it might look like one of these three examples. So what I want to do is I have kind of outlined the steps that I use when I solve multi-step problems, and I'm going to share my steps with you. I have also color coordinated them with an example so that I can show you what I'm talking about. So I'm going to slide my notes up a little bit. You can always pause the video if you need to and if I'm talking too fast. So here is my example. And what I have are my solving steps. This is what I have found works best for me. The example that we're going to look at with this is right over here, this very first line. is an equation that I have given myself that I need to solve. My first step is going to be looking for the distributive property. If I see the distributive property needs to happen, I'm going to do it. The reason why I know it needs to happen in this case is because I have parentheses and I have a number right next to a set of parentheses. So I can do the distributive property here, and I can do the distributive property here. So that's why I've underlined distributive property in purple, and then I underline the second sentence in purple because this is what it looks like after I did the distributive property. So 8 distributed to 4 got me 32. 8 distributed to the minus 2x gives me minus 16x. 4 distributed to 3 gives me 12. 4 distributed to minus 5x gives me minus 20x. And then I brought the plus 4x down because I haven't touched it yet. Now I'm ready for my second step. I need to combine the constants that are on the same side of the equation, and I need to combine the variables that are on the same side of the equation. So what I'm going to do is I'm going to look at this and I'm going to say, okay, looking at this side, these are not like terms. So in a sense, this blue step is combining like terms. These, nope, not like terms. This one has an x, this one doesn't. I go over here. Okay, this is a constant. This one has an x, this one has an x. I can combine negative 20x and 4x. So that's why I underlined negative 16x in blue. I was combining, I called these variable terms. These are like terms that have a variable. And I combined them to minus 16x. There were no constants on the same side that I could combine. The next step, combine the constants on both sides. So what I mean by that is that I have a constant on this side and I have a constant on this side. They're on opposite sides and I want to get them together. In this case, I decided to move the 12 because it's easier to move the 12 for me than it was to move the 32. I would rather subtract the smaller number than subtract the bigger number. In order to move something from one side of the equal sign to the other side of the equal sign, you have to use the opposite operation. In this case, since it's a positive 12, I used subtract 12 because minus is the opposite of positive or adding a 12. If you subtract 12 from one side, you have to subtract it from the other side. So that is my green step. 32 minus 12 gives me 20. I brought down the minus 16x because I haven't used it. 12 minus 12 is 0, so they canceled out. I didn't have to write it down here. And then I brought down my minus 16x because I haven't used that one yet either. Now I'm ready for this pink step. I'm going to combine my variable terms that are on both sides. I have the minus 16x and the minus 16x. I decide to move this one away from this constant because I want to have my variables on one side and my numbers on the other side. So I decided to move this one away. Since it's a minus 16x, I did the opposite and I did plus 16x. And then I did plus 16x to the other side to keep the balance of the equation. Minus 16x plus 16x gives me 0. Minus 16x plus 16x gives me 0. 20 plus 0 is just 20. So now I need to get the variable alone if possible. In this case, my variable canceled out, so it's not possible. But notice I'm left with a value equal to another value. Remember, that is my finish line. Value equal to another value. So I know right now that I am done solving this problem, and all I need to do is decide if it has one solution, all solutions, or no solution. This is a not true statement. Therefore, there is no solutions for this problem. Sometimes you might end up with your variable still here, and then you would need to solve that, because that would be a one-step equation, and you know how to solve that, to get that variable all by itself. So that's why it says if possible for the orange. Sometimes it won't be possible, sometimes it will be possible, and you just use your skills from solving one-step equations to get the variable alone. So there are my steps for solving a multi-step equation, and I hope these notes have helped you kind of clear some things up and better your vocabulary when working with these equations. See you guys.